So today we're actually going to be looking at the topic of fractions. We're going to be doing adding, subtracting, multiplying and dividing fractions. So we're going to use some techniques and shortcuts to explain and show our steps. So on the topic of fractions, we're going to look at this first question. So again, I'm going to kind of explain some of the instructions you get with some of these questions so you can kind of recognize the specific that they're kind of looking for. So if we're looking at this question, write in lowest terms, and we've got 9/10 plus 4/15. And I'm going to write it down the board because ideally that's what we want to do as opposed to going across. So when we're adding and subtracting fractions, this is the trickier part of working with fractions. When we come on to multiplying and dividing shortly, that's a little bit easier. Okay, so there's one sort of less step that we need to consider. So when we're adding and subtracting, it's very similar, except we're just going to add or subtract the numerators as applicable. So if we have this question, 9/10 plus 4/15, I want to add these together. And then I want to write the answer in lowest terms. So again, that's something that we use with fractions because we always want to have it in the simplest and lowest way. So with this question, what we've got to do is find the lowest common denominator. So you'll see that written out, lowest common denominator. And all that means really, long term, that we abbreviate to LCD, is that we're just looking at the bottom number of the fraction. So the top number of a fraction is what we call the numerator, and the bottom number is the denominator. So it's just the denominator that we're looking at here for the first step, where we want to find the lowest common denominator of these two fractions. So we're going to identify here that we're looking at 10 and 15, and we're kind of looking at those multiples. So, just to kind of explain that, if I'm looking at the 10, I'm doing the multiples of 10. So 10 times 1, 10 times 2, 10 times 3, and so on. Okay, and then likewise with the 15, I'm going to look at the multiples of 15, 15, 30, 45, and so on. Okay, now the key thing is that we want to find the number where they join, initially here. So 30 is the lowest common denominator here. Now we can use, multiples of that, 60, 90, but we actually want to choose the lowest one because then it gives, allows us less work that we need to do. So what we want to do now, once we've identified that 30, is we want to rewrite the fractions as what we call equivalent fractions. So we have a denominator now, common denominator of 30, and we have to rewrite these fractions so they have the same value. So the way we look at that, we're going to look at 10. We know that if we multiply 10 by 3, that gives us the 30. So we have to do exactly the same now to the numerator. So 9 times 3 is going to give me 27. And so now this fraction is identical to 9/10. And you can check that on the calculator. So any fraction, so if you do 9 divided by 10 on the calculator, that will give you 0.9. And the equivalent fraction that we've just worked out, if you divide that on the calculator, 27 divided by 30, it should give you 0.9 if we've done it correctly. Okay, so that's kind of why we do that. It seems strange why we do that kind of procedure for adding and subtracting fractions, but that's the reason why. We have exactly the same value represented now, but we have the common denominator. So with the second fraction now, we know that if we multiply 15 by 2, that gives us the 30. So we also have to do 4 times 2, and that will give us 8. So we now know that 4/15 is the same as 8/30. Okay, we've got the same denominator, so we know our answer will have exactly that same denominator. Okay, we're not adding the denominators, that's just going to give us a denominator of 30 here. But what we are going to do is add the numerators. So we've got 27. Okay, so 27 plus 8 is going to give us 35. So now we've got an answer of 35 over 30, okay? But the key thing here is that we want to write it in lowest terms, okay? We don't want to leave that answer because we can see that both the numerator and denominator, actually we can divide them by the highest factor we can see here, 5. Okay, so we can divide 35 by 5. That gives us 7. 30 divided by 5 is going to give us 6. So now we've actually written our answer, and I always kind of like to highlight my answer, 7 over 6. Now this is what we call an improper fraction. And basically it's fine to leave the answer like that unless you were given, particular instructions to write the number in a certain way. So as an improper fraction, it's perfectly fine for you to leave that answer there, 7 over 6. If we actually wanted to write it as a mixed number, so again, this is something that we use terminology with fractions, is we want to write a whole number and then a proper fraction. So the way to look at this is, there's different ways that you can do this, is we've got 7 over 6. So basically how many 6's go into 7? Well, that goes once. And we know that our answer always has the same denominator of 6. So, the easiest way to remember this is then we're going to do 1 times 6 gives us the 6. We've got a 7 in the numerator, so we're just going to subtract the 6 from the 7. So we've got a remainder of 1. So if we wanted to leave the answer, or if you want to write the answer as a mixed number, 1 and 1 over 6. But certainly an improper fraction, it would be my kind of preference. So that's kind of an introduction as to how we add fractions here. Okay, the other point just to note is when we're working with fractions, we don't want to work with decimals, again, unless we're specifically told to do so. So we don't really want to give our answer. Again, we can check what this is using a calculator. I just have a scientific calculator here. So if we know that 1 divided by 6, that's going to give us 0.1666 recurring. We've got 1 whole, so 1.1666. Okay, and mathematically we might write that 1.16 and we might put a dot or a little line above the 6 to indicate that it's going to be repeating to infinity. We don't actually want to write our answer as a decimal unless we were told specifically to do that. Okay, so question 2 we're going to have a look at, and we're just going to introduce this kind of element of mixed numbers now. Okay, so we're going to add together these two fractions, which are both mixed numbers, 5 3/4 plus 3 1/2. Again, I'm just going to kind of work down the page. So there's actually 2 ways that we could do this question, okay, both if we're adding or subtracting. Now, my preference would be to change the mixed numbers into improper fractions. So that's kind of the standard that I would suggest, and that's what I would kind of use. Because when you come into doing subtraction, it gets tricky if the first fraction is smaller than the second fraction. So there's some different considerations there. So first thing, as soon as you see a mixed number with fractions, always change it to an improper fraction. That just really helps longer term. So to change the 5 3/4 into an improper fraction, we're just going to use the whole number. 5 times denominator, 5 times 4 is 20. 20 plus 3 gives us 23 for the numerator, and the denominator stays the same. Okay, likewise for 3 1/2, 3 times 2 gives us 6 plus 1 gives us a new numerator is 7, and the denominator stays the same. Okay, same as we did previously. Now we've got 2, as it happens, 2 improper fractions, and now we're going to find the lowest common denominator of them, and we're going to identify that we've got a 4 and a 2, do the multiples of each. The first time that they match is going to be at 4. So we know that we need to have a common denominator of 4 here, and then we have to write the numerator accordingly. So the first fraction is done for us. And so we've got 23 over 4. And the second fraction, we know that when we do 2 times 2, that gives us a denominator of 4. So likewise, we're going to do it with the 7. 7 times 2 is going to give us 14 here. Okay, then we've got the same denominator. We can just add the 2 numerators. So that's going to give me 37, sorry. Okay, so it's good. It's easy to make a mistake, so don't do that. So 37 over 4. And again, I would be, we've got an improper fraction here, so I'm just going to remind us about that. Now, what I might do with this particular question, unless we had special instructions, then obviously they would take precedence, but I would then rewrite this improper fraction as a mixed number, just so that it matches the type of numbers that it gives us originally in the question. So again, you can use the calculator to help you do this. You can do it with mental math as well. So any fraction, we know 37, if we divide it by 4 on the calculator. Okay, and I'm just going to do that. So we get 9.25. Okay, so when we do this, we're not interested in the decimal, we just want to use the whole number. So we know the whole number here is going to be 9, and we just have to work out now, we know the denominator is the same, so it's going to be over 4. We just need to work out what the numerator is so that we can write it as a mixed number. So we know 9 times 4 is going to give us 36. We've got 37, so we can just subtract the 36 from the 37, so we get 1 remaining here. So ideally, we want to give our answer as 9 and 1/4, 9 and 1 over 4 for that question. Okay, now there is an alternative method. I'm just going to switch up the colour here. So either for adding or subtracting, you can actually split the whole number with the fraction. So if we had the same question, we're still adding these 2 fractions, what we could do is split these up. So the whole number, we've got 5 plus 3, so we know that gives us a whole number of 8. And then if we look at the fractions separately, 3 over 4 plus a half. Okay, so now we can just add those 2 fractions separately. We've got a whole number of 8, but now we're just going to look at the fractions and adding those together. So again, we're going to identify that we need to have a common denominator of 4 for each fraction. We can just put in the first fraction. We know we're multiplying 2 by 2 to give us 4. So we need to do 1 times 2 gives us 2 here for that numerator. Same denominator, add the numerators, that will give us 5 over 4. So now remember, we've got our 8 as our whole number, and now we're going to add that to 5 over 4. Okay, with this fraction here. Now this is an improper fraction, so it means that actually we can change that into a mixed number. 5 over 4, how many 4s go into 5? Well, that's 1. 1 times 4, 4, so we've got 5, subtract, so we have a remainder of 1, and the denominator stays the same. So basically we can change that into our mixed number here, and then we can add these 2 together so that we get our final mixed number. 8 plus 1 is going to give us 9 as a whole number, and then we've got a quarter here. So now we've got our solution, 9 and 1 over 4. Okay, so you can see that that's another important aspect in math, is that there's often lots or different methods that you can use to do a question. And sometimes we don't always see what maybe is the quickest method. We might just use something that we feel most comfortable with. So, definitely use what you feel confident using. But there is that option with adding and subtracting fractions. But I would highly recommend that you always, when we have mixed numbers in the question, that we just change those to improper fractions and follow through, and then give our answer as the simple, as the mixed number at the end, as opposed to the second method I mentioned about splitting it up. Okay, so that's adding fractions. Subtracting is very similar. Okay, so we're just going to have a look at another question here. So we want to write our answer in lowest terms. So we've got 5 3/4 subtract 3 1/2. Okay, so I've just used the previous question, but now instead of adding, I'm just going to subtract. Okay, so again, we've got mixed numbers, change them to improper fractions, ideally. 5 times 4 is 20, 20 plus 3 is 23, the denominator stays the same as 4. Now we're subtracting. The second fraction, 3 times 2 gives us 6, plus 1 gives us 7, over, and the denominator stays the same. Okay, we've already done this in the sense that we know that the lowest common denominator is 4, so we know our first fraction is the same, and we're going to change the second fraction, so it's going to have the same denominator 4. We know 2 times 2 gives us 4, so 7 times 2 is going to give us 14. Okay, so now we know our answer has the same denominator of 4, and we're just going to subtract the numerators. So 23 subtract 14 is going to give us 9/4. Again, because our question, we had 2 mixed numbers, it's sensible, to write then the answer in the same format as a mixed number. So we have 9/4. Okay, again, you can use the calculator if you want, but we know how many 4s go into 9? Well, that's 2, so our whole number is 2. And 2 times 4, so we know our denominator is still 4, is going to give us 8. And then we can subtract that from the numerator, 9. 9 subtract 8 is going to give us a remainder of 1. So we've got 2 and 1/4 for our answer, written as a mixed number. So that's subtracting. Okay, just the numerators we just subtract instead of add, depending on the operation. Again, sometimes you'll see that kind of word, operations. That just means, are we adding, subtracting, multiplying, or dividing? Okay, so that's kind of adding and subtracting with fractions, which is the trickier kind of aspect to fractions. So now if we have a look at going on to multiplying and dividing fractions, so they're a little bit easier, but there's certain rules that we need to remember. Okay, so if we were looking at answering to simplify this multiplication, so we've got 4.5 times 1 and 3/5. Okay, again, I'm just going to kind of work down the page here. Definitely, multiplying and dividing, always write mixed numbers as improper fractions, okay? And we cannot split the whole number and the fractions because of the operation of multiplying. So again, kind of use this as your rule. No matter if you're adding, subtracting, multiplying, or dividing, use that as your go-to. So 4.5 is a mixed number. We want to write it as an improper fraction. So we know the denominator stays the same, it's 2. 4 times 2 gives us 8 plus 1. So that means that we have 9/2. And then we're multiplying by 1 and 3/5. So 1 times 5 is going to give us 5, plus 3 is going to give us 8/5. Now, there's something clever that we can do when we're multiplying fractions, is that we can actually look diagonally. And what we mean by that is we can actually simplify this before we multiply. So I'm looking diagonally at the 8 and the 2. Okay, so I can see that both of those numbers are divisible by 2. We can divide them by 2, so we get a whole number answer. So 8 divided by 2 gives me 4. 2 divided by 2 gives me 1. I can also look at the other diagonal, 9 and 5, but we haven't got anything that we can divide there. So at this point, we want to now just complete the multiplication. So we're just going to multiply across the two numerators. So 9 times 4, 9, 18, 27, 36, over now 1 times 5, and that gives us 5 here. Again, we could leave it as an improper fraction, but ideally, because the question had mixed numbers, it's better if we actually rewrite it as a mixed number, unless we were told otherwise. So 36 divided by 5, okay, we know is going to give us 7, or okay, I don't know what it's going to, just do that on the calculator. That's going to give us 7.2. Okay, if you use this method, we just want the whole number, so we know that we've got 7. Okay, how many 5s go into 36? 7 times. 7 times 5 gives us 35. So then we can subtract that from 36, so we have 1 remaining, and our denominator stays the same. So the message is, always with fractions, the denominator stays the same. So now, writing the answer, instead of writing it as an improper fraction, 36 over 5, we can write it as a mixed number, 7 1/5. And that's all we need to do. So multiplication, much easier. We do not need to have a common denominator when we're multiplying and therefore dividing. So we haven't got that step, which makes it a lot easier to do multiplication of fractions. So if we actually have a look at the next question, okay, we have 7 over 9, and now we're going to divide by a whole number, 7. Now, anytime that we have a whole number, we can make it, or we can write it in a fraction format by just putting it over 1. So we already have a proper fraction here, we're dividing, and we've got a whole number of 7, so we can just write that with a denominator of 1. 7 over 1 equals 7 as a whole number. Okay, now when we're dividing fractions, there's just one extra step that we need to do. We actually have to change it into a multiplication. So we can't do the division at this point. We have to change it into a multiplication, and then we follow the procedure for multiplying fractions. So how we do that is we always write the first fraction as it is, 7 over 9, change it to a multiplication, and we flip the second fraction only. So that's 7 over 1, we flip it around, 1 over 7. Now again, we can look diagonally and simplify before we multiply across. So we see we've got 7 here, so 7 diagonally here and the 7 here. So we know both of those are divisible by 7, we can divide them by 7, and that gives us 1 here. So now we can continue to just multiply across. In the numerator, 1 times 1, and in the denominator, 9 times 1 gives us 1/9. So now, 7 over 9 divided by 7, the answer is 1 over 9. And you know, I would have no idea what the answer was until I followed through the calculation here. And that's just a proper fraction, 1 over 9. But if you ended up with an answer that was an improper fraction, say it was 9 over 7, then you could just leave it in that format. That's fine, unless you had extra instructions to do it otherwise. So the key takeaways for fractions. First one is that for any operation, whether you're adding, subtracting, multiplying, or dividing, I really encourage you to write mixed numbers as improper fractions. So that's always the go-to kind of method. So for any operation, write mixed numbers as improper fractions to then continue. Remember, you do have that kind of option with adding and subtracting, but I highly recommend you just follow through with the improper fractions. And certainly for multiplying and dividing, you need to definitely change any mixed numbers into improper fractions. Okay, the second point that I'd like to note is that you should always write your answer in lowest terms as a fraction, unless the question states otherwise. Okay, so always write your answer in lowest terms. So the key thing here is as a fraction, unless otherwise stated. Again, the question might ask you, write in lowest terms or simplify. But if it doesn't give you that information, then you have to remember to do this. You always must write your answer. It's implicit that you write your answer in lowest terms. So the third takeaway is, always remember that when you're dividing fractions, you have to change it into a multiplication and simplify diagonally, just to sort of do it as the quickest that you can. So always change division of fractions into multiplication and simplify diagonally. Sometimes you might see the terminology of cancel diagonally. I prefer to use simplify, but you can see that. And there's just a few questions for you to try on your own. So I'll just write these out. And then the answer I'll just write next to it and circle that. So please try these yourself. So that's kind of the lesson on fractions today. I hope you found that useful. If you need extra help, please reach out to me using the links provided in the description below. Also, check out the other videos in the series. Thanks for watching.